Thanks for tuning in for another episode of Math with Mullins. Today we're going to look at lesson 6.5, indirect proof and inequalities in one triangle. So we're going to look at indirect proofs, listing sides and angles of a triangle in order by size, and then use a triangle inequality theorem to find possible side lengths of triangles. First thing we want to talk about is what is an indirect proof. That is when you can make a temporary assumption that the desired conclusion is false, but then be able to prove that's a logical impossibility. So then you can prove the original statement is true by using a contradiction. A lot of this is tough to understand just with this one vocabulary term, so at least have those 3 blanks filled in for your notes, and then we'll start to write some as examples. So there are 3 steps we're going to use in order to write indirect proofs. The first step is to identify the statement you want to prove, which is your given, normally, and then you're trying to connect it to the proof statement. You're going to assume temporarily that the statement is false by assuming that its opposite is true. Once you do that, then you can do step 2, which is reason logically until you can reach a contradiction. And then step 3, point out that the desired conclusion has to be true because the contradiction proves the temporary assumption false. So we're going to use that step in this first example in your notes. So if you can slide down to here, and we're going to type this one out because it's going to be ending up being kind of like a paragraph proof. It says, write an indirect proof that in a given triangle, there can be at most one right angle. So first we're going to try to disprove other things. What would happen if there are more than one right angle? So we are given triangle ABC, and we want to prove that ABC can have at most one right angle. Okay? So let's start by writing down our first step. Identify the statement that you want to prove. So assume triangle ABC has 2 right angles. And we're trying to prove that, maybe let's say that's angle A and angle B. Then step 2, it says by definition of right angles, A has to equal 90 degrees and B has to equal 90 degrees. But by the triangle sum theorem, the measure of angle A plus the measure of angle B plus the measure of angle C has to equal 180 degrees. Using substitution, we can say 90 plus C equals 180 degrees. So C equals 0 degrees. Triangles cannot have any angles of 0 degrees, so we have a contradiction. So step 3 is when we can point out the desired conclusion must be true because the contradiction produces a temporary assumption that is false. So the assumption that triangle ABC has 2 right angles is false, which proves that triangle ABC can have at most one right angle. Okay, so we're going to try to follow that same dialect as we go through some more examples. Next up, we have a triangle longer side theorem. This is where we're going to talk about some inequalities. If one side of a triangle is longer than another side, then the angle opposite the longer side is larger than the angle opposite the shorter side. So for example, over here we see AB is longer than BC, so that means measure of angle C should be bigger than the measure of angle A because 8 is across from C and 5 is across from A. And since 5 is less than A has to be less than C. We can also use the triangle larger angle theorem to talk about some opposite angles. If one angle of a triangle is larger than the other, then the side opposite the larger angle is longer than the opposite side. So again, if I know that angle A is 50 degrees and angle C is 30 degrees, that means this side has to be longer, which is BC, than this side. This side must be shorter, okay? So we're essentially just using angles and sides to measure out which angle should be larger, which line segment should be longer. So we're going to use an indirect proof here. Doing our steps 1, 2, and 3. I know that the measure of angle A is greater than the measure of angle C, so I want to prove that BC is greater than AB. Here we go. So step 1, identify the statement you want to prove. Assume BC is not greater than AB. Okay, so we're writing temporally that this statement is false. So we can either have BC is less than AB or BC is equal to AB. Okay? Step 2, reason logically until you get a contradiction. If BC is less than AB, then angle A, which is across from BC, is less than angle angle C by the triangle longer side theorem. If BC is equal to AB, then angle A must be equal to angle C. So now that we've contradicted it, we can go on and write our third statement. The desired conclusion has to be true. So the assumption that BC is not greater than AB is false, which proves BC is greater than AB. All right. Next up, we got a few examples here. It says list the angles of ABC in order from smallest to largest. So smallest, we can start with the smallest side, BC. So that's angle A. The next 12, which would be B, and then C. So I'm using the lengths of the sides to prove the sides that are going to be longest to shortest, or shortest to longest. List the sides of ABC in order from shortest to longest. Again, starting with the smallest angle. The one thing we're not aware of is this angle over here, so we could do 61 plus 59 to help us. It's 10, 11, 12, and then 120 minus 180 is 60. So this is 60 degrees. So again, start with your smallest angle. We're going to go BC first, and then 60 degrees is next. That'd be AB. And then the last one, 61 degrees, which would be AC. Okay. Last little bit, the triangle inequality theorem. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. So as long as you can add two sides together, it should be greater than the third side. And it doesn't matter what combination you choose, just as long as you can choose and prove all three of those combinations. We're going to try a word problem here. It says a triangle has one side length of 6 and another side length of 15. Describe the possible lengths of the third side. So we have a 6, a 15, and we don't know this other side. So you can think about it as that. If X is smallest line, maybe that we say 6 plus X has to be greater than 15. We can solve and say X is greater than 9. So that's an opportunity or possibility. We could also have a portion where if X is biggest, meaning we can maybe do using that 9, adding it to 15, and it still has to be greater than X. We're going to get 24. So X would have to be less than 24. So it can be X greater than 9, but less than 24 for all possibilities. Okay, the last little bit, decide whether it's possible to construct a triangle with the given side lengths. All of my formatting was off here. So the first one is 4, 9, and 10. The second one is 8, 9, and 18. And then the third one is 5, 7, and 12. Okay? Add together and show all possibilities. Is 4 plus 9 greater than 10? Yes. Then we could do 4 plus 10. Is 4 plus 10 greater than 9? Also yes. And then we can do our last possibility, 9 plus 10 is greater than 4, also yes. So yes, each sum of two sides is greater than third side. Okay, do the same thing here. Is 8 plus 9 greater than 18? And right away, that's not true. So you can stop there and just say no, because 8 plus 9 is not greater than 18. The last one, we can try 5 plus 7. Is that greater than 12? Nope, so right away, no, because 5 plus 7 is not greater than 12. Okay? That will conclude our notes today on our lesson 6.5. Thanks so much for tuning in, and we'll catch you next time as we wrap up chapter 6.